Hello, everyone. I think my microphone works today, but for whatever reason, we are not seeing Rebecca's webcam, because of course we're not.
Hello.
Let me switch. Yes, you're a ghost. Yeah.
Yes.
There's two of me. And now let's see if we can see Rebecca. Can you try speaking? Maybe we can at least hear you.
Hello. I'm here. The ghost of Rebecca exists.
I think people can hear you.
Hopefully.
Yeah, because I briefly tried putting myself there in the slot to see if it would work, but it doesn't. So I'm gonna try once more, and if not, Rebecca, I'll ask you to stop and restart the webcam. Maybe that will work.
The webcam.
Yeah.
Skype.
Okay, no, wait 1 second. Not yet. Maybe. Yay! Something else had fucked up. And now it's only weird. And now it's fixed. Technology. How does it work? I don't know. Hello, it's been 2 years and we cannot fucking get this right on the first time. Hey!
Hello. Am I not a ghost anymore? Because
now people can see you.
Hey. Hello, everyone.
Welcome back. Welcome back. I'm super excited because it's a graphics and animation episode, and thus but I'll be honest, I'm always excited about stuff, but there's two things that I love more than anything else. One is graphics and animations, and the other one is tooling. So we got tooling last week. We have animation this week. It's almost as if I were the one picking the topics.
Feeling that next week is gonna be pizza, but
no, next week we're off. Yeah, as a reminder,
so
next
it
week
is
we're
gonna
off.
be pizza.
Now I have to
just
go
not
get
live.
a pizza on Wednesday.
Just gonna be live.
Yeah, fair enough.
You need an episode where you live stream yourself eating pizza. I contemplated bringing my own pizza to the stream.
I considered that at the beginning, but then I was like, nobody likes seeing people eat.
True.
I mean, it's not like a ASMR kind of situation. So I could be like,
We are not that kind of stream. It's not that kind of channel. No, Sebastian, that's just gross. Anyway, so
I know it is. That's why I'm not doing it normally.
it will make us probably rich because
Yeah.
the way internet works. But they will be still like, I don't want to leave that kind of legacy to my baby. So,
Yeah.
Oh yeah, my
That-
father, was famous because he was eating pizza live on Twitch. Like that.
As Mark said, it's not a pretty sight.
Yes, Mark.
Hey, the food was good. It's
anyway.
not my fault. Okay. So, why are we even here? It's not to talk about food.
So how do we want to do this? So we have Rebecca that does and lives and breathes and knows everything about animating things and
he's not a
compose.
ghost.
She's here and she's real. And she's also the real deal. So let's leverage this, Sebastiano.
Yes. So today we are gonna go back to the JetLagged, which is what I feel right now. The JetLagged sample, which is something you might remember we talked about with Simona last year, was it? Yeah, last year. God, time flies. And yeah, Rebecca, you were supposed to be there as well, but then you had a last minute problem, so you couldn't join. So today we have Rebecca. We said we could get Simona back again, but then it wouldn't be fair. So let's
Probably was like, I'm done with you guys.
Yeah, I remember that she kind of threw you under the bus at some point.
Yes.
Probably was offline. I can't remember, but yeah, sure.
She did.
I'll have to find her. Find what she said.
Maybe someone clipped that specific point in time in the stream, and it's like, this is how friendships end.
YouTube Shorts kind of.
Yeah.
Yeah, we were supposed to, unfortunately, I was supposed to travel for ADS and do the talk with her. I'm so glad she managed to like pull it off and do an incredible job of that talk and showcase this app that we made together. But yeah, glad that I can be here and chat about some graphics and animation.
She was very happy that the whole thing was like 3 minutes, and you worked you worked on the thing for like weeks. And she was, yeah, we had to do. I remember some very high pitched sentences about how short it was and how she wanted to talk about that. Yeah, but
So, before we start, Ivan, do you want to quickly do the Ivan thing, and then we can jump right into the meat, or the fake meat if you're vegan?
Very, very, very easy. Just want to remember that we appreciate your support. We reached 75,000 views on YouTube. That's no joke. So thank you also for supporting us on the VOD side and on the not on the live. You can support us financially. It sounds way more ominous that it is. You can buy stickers, you can buy the metal pin, you can buy the t-shirts. We have a bit of merch on a couple of websites that I'm going to link in the description and in the chat. And you can subscribe for free on Twitch if you have an Amazon Prime subscription. You can connect your Amazon gaming account to your Twitch account, and basically every month you can subscribe for free to one channel. In the options, you will see Prime, subscribe with Prime for free. And if you toggle that and subscribe to our channel, we get $1-ish. And we can basically give away stickers, and we can pay for shipment for when we do the giveaways. So thank you for the support.
Are we doing a giveaway today?
I'm not sure.
Totally prepared.
I broke the ball. So
let's take this week and next week to reorganize the giveaway stuff, because we might have been kind of improvising it for a while.
Yeah, well, I mean, yes, I broke the ball. Sorry, I'm rewriting everything.
It's fine. It's okay. We'll have more stickers and more stuff to give away when we're back in March.
Fantastic.
Okay, so
let's go.
Fuck you, fly. Sorry, there's a fly that has been flying around here. There's like a square meter around my face for the past hour. I'm trying to get her to go away, but anyway, we were saying this is not derailed entirely.
It's a very adult reaction to a fly. Anyway.
So, Rebecca, should I share your screen?
Yes. Please.
You're welcome to. Oh no. Where do we want to start? Like, where did Simona leave off? I'm assuming like
you're asking questions that I would have had an answer to 2 months ago. I think where we were left was that we covered the layout logic, but we didn't cover the animation and we didn't cover the drawing.
Cool. Okay. Yeah, I guess I can run through it, and then we can you can stop me and we can chat about things and redo things, stuff like that. Cool. Yeah. So for those that haven't seen this app before, we've released a new sample called JetLagged. It is a sleep tracking app that, well, like a fake sleep tracking app that is just one screen, but it is a demonstration of custom layouts and graphics and animations in Compose. So the talk that we did previously, or that Simona presented at ADS, is live on Android developers channel that you can watch. But it basically is a little graph that animates when you click on it and expands to show more details about like your sleep states. So you can see it in the awake period of time, your REMs, sleep cycles, all that kind of thing. It differentiates when you click on it for more details. It also has a little emoji on it for what we call like the sleep score. So when you like had a really short amount of time, the emoji is like sad and happy if you had a good sleep, that kind of thing. So yeah, so today we can
Sorry, but does it ever happen as an adult? Does it ever happen? I mean, have you ever used the emoji that you got a good night of sleep? Because it never happens to me anymore. So just asking.
I don't have kids, so sometimes, yeah.
Yeah, fair enough. Fair
Yeah,
enough.
sometimes I get a
Guess
great
it's on
sleep
me.
score as well.
Oh, fair enough.
Yeah, so this app is just this graph. There's nothing else more to it. It's got this little animated background as well that we can go through. And yeah, so as far as I remember, Simona's gone through how to like lay out this graph. So how to draw this hours bar, the days on the side, and then how to position this bar in this graph itself. So like to give it the size and the position, the X and Y offset of where this little bar will be placed. So what we will probably cover today is just like the inner part of this bar and how we drew that and animated it. And then the header as well. And we can dive into questions or anything that comes up as we go.
Yes, sounds like a plan.
Yeah. Cool. So I guess if you have looked at the code is also available. I think it's been linked already.
Yeah.
It's been linked. So we can look at JetLagged time graph is what we've called it. And inside it, we've defined this time graph composable, which has the hours header, the day labels for the side, and then we've got the bar composable, which is what will be called for every index in this graph. This bar composable will be created. So currently, we've got this custom composable called sleep bar, which is doing all this fancy animation logic and drawing logic. But I wanted to show, like, just so that we can understand where we are in this sample. If I had to just replace the sleep bar with a box and like a color and a size, a height, and some padding, we can see where exactly we are in this whole graph that we're drawing. And then we can get into the details of the actual sleep bar and drawing out all the sleep data. Yeah, so we have just a simple box that we could start with that has a size of 36 dp, a background, and you can see the offset and the offset, the X and Y offset, and the length of the bar is already calculated for us by the actual graph that Simona drew in the previous episode. So everything else that we'll be drawing inside, all the details and the actual clicking will be done now in the sleep bar composable. Cool. So we can get rid of the box now. We see where we are. So the sleep bar itself has a fair amount of logic inside of it, but if you have a look at it, it might be a little bit overwhelming to start with. But if you like kind of think about building this up bit by bit, it's a little bit easier. So what I would say is like, let's forget about the animations for now and let's get to like the end state. So we know the start state of our bar. If we run this right now, the start state is like a solid like round bar that is shown on screen and a couple more elements like the little text emoji and the visibility, that legend. So if we think about, we've got two states here. We've got this collapsed state and we've got the expanded state. So when we are in the expanded state, we want to actually create a path here that we will animate between. So in this one, we're going to be generating a path between these sleep periods. So we've got information that we need. So all the information to generate this graph is in a sleep day data class, and I can show you what that contains. So the sleep data, this is per day. So each sleep day has a list of sleep periods, and each sleep period contains the start time and end time of that sleep, and it contains the type of sleep that you have gotten. So if it's REM, light, deep, or awake. So with that list of sleep data, was someone saying something?
No. I'm just. I said nice because I just think aloud. Sorry.
No, that's cool.
I'm trying to follow everything, and I was like, oh, that's nice.
Cool. Yeah, so we have this sleep data that has a start and end time. So what we want to do now is generate a path, which is a graphics concept, a path that we're going to add all these little periods into to generate this whole path over time. So if I go back to where we were, so we can ignore all the sleep data stuff for now. If we look at the actual path that is generated, we have a function probably called generate path. So we have this generate sleep path function, which takes in the size of the canvas that we're drawing in and the data that we want to display. So the start and end times of each sleep period. And then everything else is kind of just like part of the animation stuff. So like the width of the whole thing, and that it's not really that important to like how exactly this works. But basically for each sleep period that we have, so we create a path, the start of the path that we want to draw on screen. And this path we can add things to. So we're going to be adding like a rectangle, a line, a rectangle, a line, a rectangle, a line for each sleep period in that day. So this is the logic for it. It's basically just a lot of maths to get to the point of like what you want to see on screen. So things like calculating how wide the bar should be based on the overall width of the whole screen and that the time at which how long that sleep period was for. So if the first sleep period was only like 1/10 of the width of the whole screen, that's what these initial calculations are doing, calculating that like percentage and then creating different parts of the path. So ignore like the lerping and all that for now, we will get to it. But the first step is like if there is a previous period in the list of periods, because we're basically doing a loop that's going to loop through all of them, create a line between them to go from the top of the start of the one to the end of the next one. So that's what this first step does. And then it actually goes into like the adding of the path. So we then add a rectangle per sleep period that represents the width of the period based on how long you've slept in that period for, and the offset. So that's also going to be a calculation based on like how far you are and how big the size of the thing is. So that adds the rectangle in this graph. And then the next step is to just move, which a move to command doesn't do any drawing on screen. So line 2 actually draws a line. Add rect just adds a rectangle to the whole like output path. But the move to just does a like an invisible move of your like pointer to the next point in on your graph that you want to draw. So in this case, we want to move to the next, the middle of the next sleep period so that we can start from there for our drawings. So this just loops over it and like assigns the period to the next one so that we can get like context of where we were in this whole graph. And this path is generated. Don't worry about like the percentages and the width and the height and that kind of thing. That's like sort of implementation detail, but the actual generation of the path is done based on the canvas size and like the height and the width of the actual area that we're drawing into. So I think the bar height in pixels is what we will be like basically animating later on. So when this changes, the path will be like regenerated to move and shift along. So we have a path. Any questions on this? I think I've probably confused everyone. Oh, we're all good.
We had a introduction. Well, I had an introduction about this stuff a few episodes ago by Mark Ellison about the path thing and drawing things. Because I'm a savage. You have to understand that I do recycle views that basically are JSON on a screen. Okay, that's the extent of my experience with this kind of stuff. So everything that is like, oh, there is a path, oh, there is move a cursor, oh, draw a rectangle, for me is just sorcery. So I really appreciate this kind of detail. So please ignore the
but
my
even
ignorance.
have you never, when you were a kid, used logo?
Yeah, that is basically that's it.
That's the same thing.
When
It's the
yeah,
same
but
thing.
it's like almost 40 years ago. Okay, it's like more than 30 years ago, and I was telling a triangle that in my mind was a turtle to move
It was
left
theoretically a
and right.
turtle.
Yeah, well, I mean, it could be anything, right? I was just a kid, but I understand. I mean, I don't have familiarity like day by day with this kind of stuff, but I understand the overall. I don't know what a lerp is, for instance, that kind of stuff. I miss that kind of information,
Yeah.
but I understand. Oh yeah, just go there, move, draw a line. So,
Yeah,
but
don't
it's a
stress
very,
about the
very
loop
complex
thing
thing
yet.
for me.
We'll get there. Yeah, this is not the easiest stuff to do. I mean, but I think like once you try break it down into smaller chunks of like, okay, this is just a rectangle and I need to move it X and Y. Oh, this is another one. I just need to adjust the size. I need to move this one down, that kind of thing. Once you break that down.
For what I usually do, I join a project that is already there, most of the time to just give a help. I really appreciate, for instance, the comments, right? Step one, draw a line, to give you that thing is super valuable for me because I don't know probably where those percentages are coming from and, things about the math of that, but I know that if I touch there, it's probably going to just affect that piece of UI badly, affect badly.
Cool. Okay, so we have a path. We're happy to move on to actually drawing this path that we've got. So we start off where we got that this path that we've got. We've generated it from everything that all the sleep data that we have. So to actually draw it, this one looks a bit complicated than what we would actually need to do. We have our sleep bar that we're drawing, this round bar, which is actually just, if you ignore all the details of like animations and stuff, it's actually just a spacer with a draw modifier used on it. So the draw modifier that I'm using is draw with cache, but there's a couple others like draw behind, which allows you to draw behind your composable, or draw with content, where you can like order your content based on if you want it in front or behind. But draw with cache is basically going to cache all these objects that we create here before we call draw. All these objects that we create, it's going to cache them for us, so we don't need to do remembering ourselves. So it's useful in that regard to use this modifier, but we could use draw behind or draw with content. And then the actual draw is we just call draw sleep bar, which is another function that we've made. And inside here, if you dive deep, you'll see it's got draw path, which has got this path that we've generated further up in our whole like stack of drawing stuff. So it draws this path, which actually doesn't draw the inside of the graph. It just draws like the outline, I think. Oh no, this one is the inside. The outline is the one below it. But if you see now, I don't know if you can see that so well on the stream. Basically, the lines.
Vertical line is missing, right?
Yeah. So.
But also the stroke pretty much everywhere is missing.
Yeah, I've lost it. Yeah. Yeah. So you can see that it only just draws the filled in area, and that's because by default draw path is doing a fill operation as the standard style. So to get those lines between it, we call draw path with our stroke style as well. So the stroke definition is coming from somewhere. I've cached it somewhere. Yeah, so the stroke that we call here for this like rounded path effect and the line thickness for in between the lines will actually be that second draw call with that same path that we're drawing. That'll be drawn on screen. So yeah, so we've got the path that we're drawing, these two paths, but what else is left on the screen? How does it actually, okay, the colors, I guess, first is the first question of like, how are these colors made and how is it drawing them over the gradient? It's using a vertical gradient brush to draw the colors. So we create a gradient with the colors over time or over like the different stops. So the first color is the awake color, and that should start at like the 0 point. And it's basically 0 to 1 divided by like these different sections of your graph. So over time, we have this these initial colors, and then it maps all the way to like the deepest red over time. So it's just one color of the whole thing applied across the path in the same way. So if you were to draw just a rounded rect with this color, it would be a whole gradient on the whole rounded rect filled in with all the same colors. So there's no like fancy color magic per part of the path, if that makes sense. It's all the same gradient across the whole thing.
So maybe you could show the difference with using a normal gradient. So it might be easier to visualize.
Yeah, let's do that. Now I need to find where I was. Okay, so we can just do, or we can do like a draw rounded rect, and you can see. Why is that not working? So if we pass in this gradient brush with the size, I think that should be fine. The size should be. So we can see this might give us or show us more if the size is still adjusting. This will show the whole like colors over time.
Mm-hmm.
Yeah. So that's the gradient that we've set up for the whole bar. But when we draw the path, it only like clips out the bits of the graph that we need. So it doesn't need like obviously every section of this square. Does that answer your question?
I like this, but so basically it's drawing it's applying the gradient to the whole let's say component, like a box, but a box that is actually missing pieces because the path is more articulated that it's just a box, right? So that's the idea. So where the pieces are not missing, or where we are actually drawing the path, this brush is applying the gradient. Is it?
That's correct. Yeah.
Slightly correct. Okay.
Yeah.
And it's doing it automatically, I mean, by itself, right?
Yeah. So without us needing to do like the brush, if we just apply it without any changes, it's doing this. The one thing that I have changed here is this end Y is part of that animation, so that initial when it's like collapsed, you only see like sort of one-ish color of the whole thing.
Mm-hmm.
Mm-hmm.
So if I had to like not have this end Y, probably when it's in the collapse state, you would see like the gradient more sort of
squishy.
Yeah. So yeah, so you can see now the gradient is not adjusted to be the size of the whole bar. It's like within that smaller bar. So with this change
here, the whole gradient in the space that you're giving it, basically.
Yeah. So this basically just elongates the gradient a little bit more to like the overall size of the whole, like the expanded state over time. Cool. Cool. So we understand a little bit about the gradient. Put this back. Come back. Nice graph. I guess the next part would be to talk about the animation of it. Yeah. Cool. So basically the animation that we set up is just taking a progress over like your click event. So on click, we switch between collapsed and expanded. So we have defined in our whole sleep bar, this whole composable for within each sleep bar itself, we define a transition. So this transition is keeping the state of expanded. So this is just our toggle that we're going to be using. So the expanded state of true or false. And this transition that we create is based on this variable. So what you can do with a transition is you can create multiple animations that tie to the same variable. So as soon as I change this is expanded to false or true, every animation that's like dependent on that will be run in the same time. So if we have a look, I've got a couple of things that are dependent on this transition or this expanded variable. And what happens is, okay, on click of the bar, we set this to is expanded. We invert the condition of what it currently is, so that will do the toggling. And what we've got defined is a couple of things that happen with this transition. So one of them is the visibility of this like legend. So we've got, for the legend, this is just a text and a little circle being drawn. And what happens is on click, we use an extension on transition for animated visibility. That will be triggered on visible if it's expanded or not. So the condition of saying when it should be visible is dependent on this state that we've created this transition on. So as soon as it is visible, the detail legend will be shown, and we can specify a separate enter and exit transition. So we fade it in with a duration, and we fade it out and shrink and expand. So this will, if you have a look at it slowly, I don't know if I can zoom this in a bit more. And then I can't scroll it.
Can you drag or spacebar drag?
Spacebar drag, no.
No, then I have no idea how it. Well, you have the scroll bars, I think. At least on the bottom, you did have it.
Yeah, I don't know. Well, that's a bit bigger, right?
Yeah.
It should be better. Yeah, so as soon as you click on it, you can see these, like the whole detail is shrinking as well as disappearing over time. So this section is just that legend, and it's controlled with this enter and exit transitions, and then it depends on this same state of is expanded, or this transition that we create from is expanded. So we've got the detail that fades in and out, and then the sleep bar also takes in this transition information. So this sleep bar is obviously going to need to know, okay, I've clicked expanded, so I need to make the height bigger, and I need to like move that text to the side, and then obviously like expand into the path that we're having. So the sleep bar takes this transition that we've got, and we create two variables. Like this could be achieved in a couple of different ways. So this is not like you have to do a graph animation in this way or something like that. Like this is just how I approached it, but you can definitely approach this in many different ways. So the first thing that I've animated is the height. So it goes from the non-expanded height of 24 dp to the expanded height of 100 dp. And this is using that same transition object, and that means it'll all run in the same time. And what we specify a animation spec. So in this case, I've got like a low bouncy spec, but we could make it more bouncy if we wanted. And then we, based on if it's expanded or not, we change the value that we want our height to have. So I've got this variable, but I've also got a progress variable for like just a value between 0 and 1 to say how far the animation has gone. So if it is not expanded, we are at a 0 progress, but if we're at 1, if we're expanded, we go to like a 1 value. So these two we can then use, these two values we can use to do things in our drawing logic. So the first thing is the height. Is we actually setting, I believe this is actually just set on the whole composable, if I find the end of it. Yeah, so the height of the composable is actually just done using normal height that we're setting on composables. And then what will happen is, because we're changing this height from 0 or from 24 to 100, is that our draw logic will execute again for every like transition in that like change of size. So we don't need to like change the size inside our drawing logic, but we will get a new reported size given to us as we go. So that's reported with, like, if you look at this dot size dot with the height, we would get that information inside our draw with cache modifier. Questions so far? All good?
Actually, I'm very, I like the fact that everything is synchronized using that transition object. I mean, it's like, you know, it's so well, immediate even to think, right? I'm giving you something that, it's like a clock. Everything is going to be based on this kind of clock. So you just use it and do your things according to this object, and eventually everything is going to move together. So it's fascinating.
Yeah. Yeah, you'll see if you try, like you could try using separate variables that aren't synchronized to that same transition object, but you might very quickly see that like they're not coordinated and they're not running at the exact same time. So you need, if you want something to be like all at the same time with the same like variable driving it, then you should probably use that transition as well. Cool. So we've got the height value that animates over time, and we saw that with when we just changed that to the rounded bar and we just clicked on it and collapsed and expanded it, the height of it was changing, and there wasn't any path like changes to that. It was just the actual size of the bar. So what's happening with the path logic, because we are now starting in the state where it looks like it's just one solid bar, it's actually not at this point. It is these separate little sleep periods, but they're all at the same like height offset, if that makes sense. So only over time, or as the animation progresses with the height, does the offset get bigger per sleep type. So a little bit like confusing to think about, but let me find that logic that does that so that I can show you. Bar height. Okay, so we have our bar height, and then we have this generate sleep path. So generate sleep path takes in the bar height and the animation progress, and that determines where it should be in the offset. So if there is, this is where the lerp comes in. This is where you were like, what's lerp? So for those
Who's lerp? Who invited them?
So for those that haven't heard of lerp before, it's linear interpolation. Basically, it just means like it's calculating a value between two values based on a like percentage or fraction that you given. Probably explained that really badly. Linearly interpolate between the start and stop with a fraction in between them. So if you have like 0 and 1 and you want a fraction between them of 0.5, your result will be 0.5. But if you have values that aren't 0 and 1, that are a little bit more difficult to calculate between, this is where the lerp becomes useful. So you can do, lerps are generally used for a lot of animation stuff. So if you want to animate between two values, you use a lerp to say, I'm starting at this value and I want to end at this value, but this is my percentage as I go along in this animation. So for colors, it's particularly useful if you have like a function that calculates like a interpolation between two colors. Then you can get like a nice animation between those two colors if you use a lerp function. But yeah, there's probably better explanations on the internet than this one that I'm giving right now.
The way my mental model for lerp is think of a 2D plane and you have 2 points. A lerp is a straight line between the two. So that, and then the percentage is how far along the line you are.
Yeah, that's a good one. It's used in like Bezier curve stuff as well.
Of course, there's Bezier curves at some point.
Not in this graph at least, but yes.
Not yet.
Not yet. So this lerp is basically what's doing the animation. So we're saying the start is at 0. So this is where it's like going to start from. And where we wanted to, the value between is the one that we want to get to is the height of the whole bar area, the canvas size that we're drawing in, and then the type of sleep that you're in. So you'll see if we're in awake or REM or something like that, we're at a different offset in this whole bar. So this will give me like a different value. So if I'm now at the light sleep, I'm going to be like halfway through that whole height that I want to get through. And how do I go back? I've changed my IntelliJ this morning, which was a bad idea. I can't find my shortcuts. Okay, so back to draw sleep bar. No, generate path we were in. Yes. So if I'm now at in a light sleep period, I'm at like I'm halfway through the height of my whole bar. And what we want to do is with this height animation, so when it's in this like expanded state, the height animation is 1. So we've got the offset that's at that correct point when it's in its settled state. But when it is at 0, the lerp between 0 and whatever your value of, whatever this value is, 0 and 100, and if you're at a 0 point in your animation, you're going to get 0 as that result. So the offset when it is in a like settled state and it's not animating is going to be 0 for everything. But as it expands, this height animation value will increase, and then it'll lerp between those two values and give us that different offset per sleep period, giving us this animation. If I changed this to not have, like, if this was just 0 all the time, you would see that it would not expand to this, to move all the sleep periods further down in the whole path. It would all just be stuck at the top level of that whole thing. So basically then we'd all be drawing every single sleep period right next to each other with the same offset Y per sleep period. So you wouldn't notice that there's a difference between them. And this is what like drives this whole animation, really, is calculating this different offset per sleep period at a different time in the height animation. And then this value, this offset Y, is then just used further on when we add the rectangle to our path. So you can see the Y of the offset of that rectangle is now at that animated, either at that animated value or that like 0 value when it's in a resting state, or like full value when it's at the expanded state. And that offset Y is used in like all the different calculations here. So as it expands, it uses that, and as it collapses, it also uses this offset Y value. And then because it does look a little bit different when it's collapsed, what it's doing is I've added just a clip path around the whole rounded rect. So if I'd remove this, if I don't clip the whole like bar, you'll see you might like the corners won't be so rounded on the like collapsed state of these bars, because it's got those individual little sleep periods at that point. So you can see it's not so rounded. Might be this damn thing now. Do I have scroll bars? I didn't think I have scroll bars.
I'm surprised.
I can't find how to get it smaller, but yeah. Well, now you can kind of see it's not as rounded in this collapsed state. So in order to do that like roundedness of the bars, I've added a rounded rect path that gets clipped. So clip path is basically you give it a path object like the one that we've just created, but it removes everything that's not in that area. So it like as if you were cutting it with scissors is what it's doing. So it's clipping away everything that's like outside the bounds of that path. So here I've got a rounded rectangle path, and what I do with this rounded rectangle path is animate that too. So it gives it a nice like transition between this collapsed state and the expanded state. So if we look at this rounded rect path here that I've created, so the path that I create is just a rounded rect of the whole size. I hope you can't hear the chaos that's going on outside my house.
I was wondering if it's your place or Ivan's place. It sounded more like Italy than London, but then again.
Yeah. I mean, I'm basically in any country you want. Everyone speaks all the languages here. It's great. Cool. Yeah. So this rounded rect that we create is, now I'm just messing up stuff here, is animated as well based on the progress animation. So I'm doing another lerp here. You're seeing lerp happening everywhere. So it basically goes from like a radius that's the start is 2 dp to when it's collapsed, we want a 10 dp radius that we wanted to animate to. I can make this more pronounced so we can maybe see this animation a bit better. But this path gets created and we add a rounded rect of the whole like area that we're we're animating, and then we clip the whole rounded rect to this, the whole sleep bar to this rounded rect that we've created. So all the stuff that we're drawing, all these draw path calls will now be clipped at that rounded rect. So we can see now it's a little bit more rounded than before. And as the animation progresses, you can see a little bit more pronounced that it does not, like it animates between these two values. Can you see it?
I have a question about this. Are you animating the clip path instead of the rounding of the actual rectangle, because you are using essentially a path, and that would be insane to try and do?
I did it for a few reasons. One is because it was a bit easier to reason about for myself. And the other is because, yeah, if you want to try and calculate different sections, I don't know, like the actual path creation for the like graph inside here would have been way more difficult to do, because you'd need to like only round the top one, the first one.
Yeah.
Like if it's at the bottom and it's at this position, then round that. So I didn't even want to think about that. I was like, that's like
fair enough. Nobody's gonna notice. Ship it.
Yeah, that's gonna be too like confusing to think about. But yeah, so this just clips it so that you can see like the animation isn't. It's better when it's smaller amounts, right? It doesn't look so.
It looks legit.
Rounded amount. Yeah, so that's that animation over there. What else haven't we covered here? So we've covered rounded, we've covered the graph, path, we've covered the gradients, the text maybe we can talk about.
Yeah, sure.
Let me put back the...
And I guess the emoji stuff is just moving, it's not doing anything crazy.
Yeah, so the text, we've finally got drawing text on canvas, yay. So because of that, I decided, okay, I can draw this little emoji with draw text on canvas. But you can also just use a text composable. Like I showed here, this legend here is, I think it's just a normal text composable, the legend. But we can draw text now on canvas, but there's also some cool stuff you can do with drawing text on canvas. So to do that, what is basically to draw this little emoji, we create a text measurer. So you need to create that in a composition. And you
remember that? Yeah, okay.
Yeah, so we've got this text measurer that we've created, and then we pass the sleep score emoji that we're going to be rendering on screen. And we call measure with that emoji that we're passing into it. And this text result contains a bunch of useful information. You can like see how big the text is going to be. Did it overflow, like line counts, paragraph stuff. It's really, really useful if you want to do like positioning of your text in strange ways. But in this case, all we wanted to do is just draw the text at the start of the whole sleep bar, because it's already positioned by the layout of the graph itself. So all we do is we pass this text result, and we call draw text in our draw scope. So we're in draw scope here, and we call draw text with this text result. And then we give it a position of where it should be drawn. So in this case, we're saying the top left should be just a bit of padding. And then, this is just a padding actually for that text. And then the animation of it, when it like moves back, as you click on it, you'll see it like moves to like kind of unobscure the graph. That is done using this translate function on DrawScope. So we could just as well have changed the offset. It's the same thing. But I wanted to demonstrate like using translate function as well. So translate will just move everything on everything towards the left. I'm really bad with left and right, so if I get them mixed up, excuse me when I do that. Basically, we're moving the width of the text. So if we had to draw something a little bit longer here, this emoji, if we had text that was like a full word or something, the width of it would obviously be a little bit longer in that case. So we take the width, the size of the text that we've measured, the width of it, and the padding that we have for this little text, and we we times it by the animation progress. So this animation progress, if you remember, was that variable that goes between 0 and 1. And we just multiply the width of it by the amount of progress of this animation and in the negative direction so that it goes like outside of the composable, like to the other side of it. And over time, this will change its value. So that's what creates the like movement as you open it and close it.
Is there like, because the animation has a bit of a bounciness to it, will the animation progress go slightly above 1 as well? As it?
So I think that's a separate variable that I've made. So separate.
I'm just asking because it's a bit, I don't remember, and it's a bit hard to tell on the screen share frame rate sometimes.
I believe because I've got them as separate like animation specs that they wouldn't be. So like you could separate them. I could say that this one must be a high bouncy, and then the animation progress will still remain the same. So we could change this even to like a certain duration if we wanted. And it wouldn't, there'll be like 2 separate animation specs. So it wouldn't have the same effect on both.
Got it.
But we could if we wanted to as well. Let's see how bouncy this looks now.
It's going to be crazy bouncy now.
Yeah.
Very bouncy.
Yeah, it doesn't look so great. I could click this all day though. Yeah, so if we wanted this one, this is a different animation spec, so it won't be affected by that change to the height. I want to put that back because it doesn't look as good. Cool, so that's the text as well. The detail, where's that detail legend, just so that you can see this content. Yeah, so this content for this little detail row is just a row with a little legend item in it, and that's a box that has a circle shape and color and a text that gives this the text for that sleep stuff. But this isn't animated, so it's just it's little emoji and then the
well, it should be. I mean, it should be animated. I mean, because otherwise we are wasting time here.
What would you like it to do?
Come on, Ivan, we're taking requests now.
Ask people in the chat. I don't know. Mark, how do you want this animated? What can we do? I mean, the half of the thing is already bouncing enough. So can we make it? I don't know. Shake. What are the options? Sebastiano.
Shake. That sounds so random.
Come on, man.
It gently fades in and out, but we've specified these different this whole composable, right? So this animated visibility is applying to the whole
to the legend, right?
Yeah, not each individual item.
So what if instead of expand, we can have them like slightly move in from the side, or just slightly move down and slightly move up as they fade?
Yeah. So
should we do up and down? I don't know.
Expand vertically. I think you get like slide in.
Should be.
What do you want? Horizontally or vertically?
Vertically. Let's try. We can try and change them and see how it looks. But I think it would look nicer if it was doing the same motion as the rest. But maybe we just want to do something different later. I don't know.
Okay.
Maybe it can come in one way and go out the other way and make it very weird.
Just make it really
spiral.
Bad.
Yes.
With a spiral animation.
No, it has to have fireworks.
Yeah.
Oh no.
What could possibly go wrong?
Yeah. Oh. Snow animation. Is it too late to have a snow animation?
One thing that we could do as well is, I mean, besides the joke of coming in one way and going out the other way, it could be that we can stagger the animations a bit, maybe, so that the text only comes in when it's already half expanded, for example, and goes out very quickly.
We could. Maybe.
So
that's how you make fancy animation, right? You stagger shit.
Yeah, it's not even that bad.
I just made it.
Well, on Skype. Yeah, the exit animation is a bit weird. But
It's like someone just learned how to use PowerPoint.
That someone is me.
That someone is me in this case.
Yeah, so
Yeah.
I just basically increased the duration of this to see it, so we could see it actually happening. But what's happening here, if we wanted it to, so you can see it like goes kind of halfway and then just fades.
Yeah.
The slide out horizontally is, by default, it goes to like half the size of the item.
Yeah, I would do like 10% or something like that.
So if we wanted, we can change.
Roman, I don't think that's gonna happen.
What's
We
the
have a
request?
request in the chat.
To redo it with views.
Yeah, sure.
No, thank you.
Exactly. I mean,
How about not?
technically
this
doable.
This is something that I want to leave to Simona for the next episode. And the SAR, it's like one of those TikTok challenge where you nominate the next person that has to do
Like,
the
not
thing.
my problem.
Yeah. So for this challenge, I nominate. Okay, I like it.
Now I've completely made it disappear. What was it? Negative. Was it negative? Yes. I'm supposed to make it negative. So this, you can specify with these enter and exit transitions, or you can specify how that X offset or Y offset goes if you wanted to change it. So you saw when it started, it was like only half the width, but in this case, we wanted to say like the whole width of the thing. So it'll go very quickly now, but
Pew.
yeah, kind of like, because it's still visible on screen, it's still drawing it, but it is actually going the whole width of the composable itself. But yeah, that's pretty much the this little graph, little part of the animation and all that.
So, but if I'm not mistaken, what's happening, and again, it might be just the frame rate, but it looks like it's doing the expansion of the bar and then it's doing the transition, the animated visibility, and the other way around. It's doing first the collapse and then, or is it just because you changed the time scale of that bit?
Yeah, it's just because I changed this duration to be longer.
Okay.
So it's all starting at the same time. It's just my spec is a bit longer for those other ones. So you can specify, if you wanted to, with those animation specs, you can specify like a offset to start it at a certain time. If you wanted to like delay it by a certain amount of time. So all these animation specs have a delay millis that you can specify, but this isn't delayed. It's all starting at the same time. By default, it's all 0. But you could do that if you wanted to. Yeah, they're all using the same duration.
Okay.
Cool. Should we do look at the little animated bar at the top?
Yes.
Cool.
That
Any
looks very
questions on this?
fancy.
Wait a second. Is it animating? I mean, I thought it was Skype messing up with the code. Jesus. Okay.
Come on, it's not that bad.
No, I'm telling you, this thing is every now and then I get everything is gray and I don't see anything anymore, and I was like, this is horrible. But now you can ask probably fancy question to Bing. Maybe Skype is gonna catch up with the fanciness as well. Anyway.
Yeah.
So let's see. How do we do this? Is it a GIF?
No, you could. I mean, you could.
What?
just put
You're a savage, Ivan. You're a fucking savage.
Whoa! I mean, it would be like the moment they say, "Oh yeah, you need to animate this," okay, where is the deadline? The deadline is yesterday. Okay, it's gonna be a GIF. I mean, there is no way around, right? I'm a contractor. I mean, this is how it works, right?
You cannot say GIF in front of Roman. That's like life lesson number 1.
But it's GIF. It's GIF because it's short for giraffe. So that's it.
Yeah, sure.
So that's why.
Regardless of how you say it, you cannot say those 3 letters together.
Yeah. I mean,
it-
we can do it with
it's good,
shaders,
right?
but maybe Rebecca wants to do something a bit. No, I don't know. More jetpacky.
Yeah, so this is using shaders.
No.
Ha!
Don't worry, I'm not going to go
I
into
see
the.
future. I'm like a wizard.
Oh no, we have looked at shaders with Roman and with Kirill as well. So people should have an idea what you're talking about. Don't worry.
Yeah, I'm not going to go into like too much. I'm not going to show you like crazy ray tracing stuff, mainly because I don't know how to do half of that stuff. So when I see Roman doing crazy shader stuff, I'm like, wow, thanks. Make me feel like I don't know what I'm doing. This is wonderful. But yeah, so this little header is a shader from basically for like a shader toy adapted one. So we have used, there are different episodes you can check out that explain shaders and more of that in detail better. But what we've done for this example is on the JetLagged screen. So we have our graph, that's a composable, but we also have our header. So we have this column header, which has got this little JetLagged text, and then it's got the sleep summary as well. So like how much time you've spent in bed and sleep summary, all that stuff. But then on this section, we have set a background to this yellow background is what I've called it. But inside this modifier, we create this shader background that's animated. So we can have a look at what this does. So unfortunately, shaders, these AGSL shaders are only supported on Tiramisu and up. So we need to check for SDK version codes. But what I've done is if it's not latest version or up, I've just drawn a gradient over time. But you could obviously put like a static image or something if you had a bit more time to do this kind of thing. So yeah, the else condition is just drawing a rectangle with a gradient of yellow variant and all that. But what this is doing for this animation is creating a time variable. So we know that we can pass this time into our shader that can be then used for this animation. So this time variable that we create is using fancy routine stuff to create this like animation
produce
value.
state. Look at that.
Yeah, someone showed me how to do it. I was like, okay, cool.
Thanks.
This looks fun. I don't know what I'm doing with coroutine stuff, but yeah. So this produces a new time variable that we can use and like pump this value into our shader over time.
Coroutines are amazing. Yay!
Yay! Yeah, incredible, amazing. I don't know what I'm doing. Looks like it works great.
Yeah, the nice thing is that you can make it work even if you don't really know what you're doing, which is something that we were missing before, I guess.
Yeah. Okay. Yeah. So we have this frame time that we like generating as we go, and then we create a shader and a shader brush. So this runtime shader is taking this little program in as input. I'll get to it now. But we are setting some variables on this like program that we've created. And the one of those variables is the time one that we've created here. So we've got this time value that's incrementing that we're passing into our shader, as well as the size of the area. So we've got the size and width of this little area that we're drawing into that we're going to send it to. And then we also want like a start color that it must start with. So we are setting a color of this like yellow that we've created and used throughout this app. And then we call draw rect with this brush that we've created. And this fancy brush is the shader that we're going to have a look at in a second. But this draw rect will then take up the whole size of this area that we're drawing into. So having a look at the shader, this is where things get like scary, is we've got the shader and I wouldn't try and understand what it's trying to do because this is difficult and like this is where things get hard. But basically what the shader is it runs for every single coordinate that you've got on your screen for that area. It tries to computes a pixel color as an output. So this main function is running and gives input coordinates for each coordinate on screen that we've got. And we need to return a value of the color that should be drawn at that coordinate on our screen. So this runs in parallel for like every pixel on screen, and it's really supposed to be super fast. And that's why it renders really complex stuff like fancy graphics, ray tracing things. But this needs to run in a quick manner and it will output little different colors as you go. So what in this shader itself, it's using these uniforms that we've put in. So uniform is like a variable. So we're giving it a time and we're giving it a resolution. So the resolution is the size of the area and the time is that value that changes over time. And then the color is another like variable that we're passing in for that like start color of the whole thing. So inside this actual function is fancy maths to get this like curve thing. I'm not going to cover it mainly because it's mostly from the internet, so you won't like, it's not going to be that useful to cover it, and I don't really know what it's doing it myself, so I'm not going to pretend that I do. But basically what we have at the end is the important part. So like the return of our function, that's a shader, we return a color that will be shown on this pointed in the screen. But you can see like through this code we are using the time variable, and that gives the like illusion over time that this is moving, as well as like the resolution and the color that we're inputting in, which is this this eye color that we start out with. So we could just, if you wanted to see like what it's doing just with it, like if we change this to just return the color that we input in, it should just be a solid color for that section. And then that might help you like visualize that this is just like the inputs and outputs for this shader. If I can make it compile. Probably doesn't, I probably broke it.
Well, we are having some explanation on the chat.
Yeah.
If you want to understand what that fancy string is doing, because to me it's just a string.
Yeah.
And that is doing something at some point.
It has syntax highlighting. It's not just a string.
Oh yeah, that's
Yeah.
super cool. I don't know how Android Studio is doing it, and but fancy string.
I can explain if you want.
Yeah, sure. I bet.
Cool. Well, now you can see it's like just the output color that's coming is just the color that we've inputted in. So yeah, we know how to do inputs and outputs in the shader. And for more info on shaders, check out the stream with Ramon and watch him do fancy stuff with shaders and understand how he does that.
That was a great episode. At some point
can,
I was like, come on, you are kidding me. It was like, what the hell is doing? Yeah.
We can do one of those things where you're like, oh yeah, so we're gonna do this shader, and it's like the draw the owl meme where it's like draw two circles, draw the rest of the fucking owl.
Yes, yeah, pretty much that's my reaction when I see this stuff. And most of the time is just as you said, I just find it on the internet. I'm just dropped it in. I actually witnessed something similar when Roman said, "Oh yeah, let me copy paste some code." Really? Yeah. Copy paste some code, and then at some point we had ray tracing, and I was like, "What the fuck is going on here?"
Yeah.
So yes.
It's a lot of how you learn, I guess, about graphics is like copy it, does it work? No, maybe I know what I'm doing now. Yeah, so that's basically this little bit of code is getting that shader and drawing it. But you could copy like another shader from maybe another shaded place like Shader Toy and try and like mess around and put those in here. And basically all you need for a lot of those shaders is like the time and resolution as input. And then you often a lot of the time we'll get these some cool shader effects that you want. So and if you're crazy, you can do Ramon's level of actually knowing how to write them.
So resolution is just for me to understand. Resolution is just the size of the container, right? So you give it like a piece of screen and it's drawing behind, right?
Yes, in this case it's using onDraw behind to draw. Yeah.
Okay, and time is just something that I think it was above, right? It was I see that it's a variable that we are injecting in the, but how? Okay, so that's the produced state. Okay, fair enough.
Yeah.
Okay.
Yeah, it uses that over time. So this could also be used, so you don't have to just draw the shader to the screen. You can also use it to like apply your shader contents. So you can apply transformations using a shader onto like composables that are already existing. So I can show you an example of that. Let me just get my one of the articles. So this is not is not jet-lagged anymore, but there is another example where I've used
magic
image
strings.
vector.
Should we
More
call
magic
shaders
strings.
magic strings?
Yes. So in this case, I'm drawing an image vector to screen, and then I'm applying a shader on top that takes the contents of that vector, that image vector, and transforms it based on the shader. So a little bit more of a better example of it being used is, this is a text composable, and then this is a normal button composable that we are normally writing in Compose, and we are applying a shader transformation to this layer in the app, and that will you can change things. You can in this case we're doing a whirly, a water effect, but you can do anything. You can apply it. I don't know, anything you can use with a shader, you can apply to the contents of your composables that you're drawing on screen. So it doesn't just have to be a static background or a simple.
This is not public, right?
This is a.
Okay, can we have the link in the chat, please? Because I'm gonna
find
show
it.
this stuff. Thanks.
Unless you have it handy.
Yeah, I've got it. That's the right link, yeah.
Fantastic, thank you.
Yeah, so this applies the noise effects to the contents. So it's a little bit different in how you use it. So instead of we were calling draw rect in that other one with the brush of that shader that we had created. But in this case, we create a render effect with the shader that we've got, and we use the content. So the image composable will be supplied into the shader as another a thing that we can query inside our shader, and that is passed in as a thing called the contents. So you can query the contents of your composable inside a shader. It's confusing, but
wait, what? No, wait, what?
So your composable's content. So we've got an image here, but we had a text and a button or a column, anything that's in a composable. We can take the contents of that, so the whole output of what would normally be rendered on screen, and pass that as an input into our shader, and then apply things onto it. So normally you would pass input as an image, and then you can change the pixels to be black and white or something like that.
Yes.
But in this case, instead of the image, we're passing in a whole composable's contents. So
you're passing a whole screen to
yeah.
shader. Okay.
So we can pass in the contents here as contents, and then inside our shader, we get a special little shader here called contents, and then we can query this contents to get the actual pixel value that's currently being drawn on screen, and then change things based on that. So here you can see I do contents.evaluate or eval, and I give it a pixel coordinate that I wanted to look up and get me the RGB value of that current pixel in the image.
Okay, but it's working on the pixel. So but how does it? I mean, it's rendering the screen itself and knowing, and then looking at the pixel, because I don't understand how it's doing it, because it's so you're passing the screen, but you're passing a rendered version of the screen, or is it rendering itself? It can't render Compose, right? I mean, now I'm losing it because this is getting weird.
You're getting in a loop now.
Yeah, now I don't understand, because this thing then is coming out of here and is probably also getting to the screen where probably Compose is rendering that. So how does it work? I mean, I don't understand.
Yeah,
is it taking a screenshot of the composable?
No, I think it's passing the actual. I don't know the exact internals of this. You can probably ask Roman; he'll know more details of this. But
no, I mean,
it's not like taking a screenshot, because that would be super inefficient, right? It's I'm sure it's passing the actual raw texture or surface that it needs to use, and then running on it. There we go. I could do it in two ways: a screenshot. We'll just get him here. Just join the call, Roman. Come on.
No, but I'm because it's working on the pixel, so I don't understand.
Yeah.
Well, anyway, I don't understand why it's super fancy, so probably I'm gonna just check this. Yeah,
Yeah,
because
so you
this
could
kind of stuff, it's impossible for me to do, right? I don't have any. The idea, for instance, when we were talking about when we were on the app and you were talking about the path and the boxes, and then it becomes the different gradient, and then it becomes rounded, and so your ability to think about that as a sequence of steps or sequence or like a set of blocks that they fit together. That's the fascinating ability for me, because I don't have I don't have the practice to look at the world as in app screens and things like that, right? For me it's more like whatever, right? It's a bit more static than that approach. So for me, something like this, it will be impossible. At some point, probably I will come up with one of this solution, because I will probably find a Medium blog post that say, oh, you can do this with a shader now, and just gonna go copy paste this and punch it as long as it doesn't work, and then it works, and then I commit, I ship it, and everybody's happy.
I think that's normal though. I think everyone has that. Like the only reason I can do a few more things is because I've already tried these things and like failed and had to learn myself. So I don't think it's like I'm definitely in that same boat with some things. Like I'll look at it and be like, I don't know how to do this. Like I don't know. Like, and I think it just comes with like doing more of it. Is okay. Now I can identify this is something that I might use in this scenario, or like you start to like once you've done a few more of them and like been in that space, you'll be like, okay, this is how I identify how to do this thing. But it's definitely not something that comes like super naturally. Like you have to think about things and like go through the motions of doing these things a couple times to be able to identify and break it down into those little like building blocks. So it's not something I don't like. It's totally normal to not know how to do this stuff. It's not easy, right? Like it's not natural to think about things like this.
Well, yeah. But I mean, on the bright side, I'm gonna use lerp for everything from now on. Everything is gonna be lerp. If I need like 3 numbers, lerp. But jokes aside, I'm super excited. Sebastiano, do you have any question about this?
No, I don't wanna open a hornet's nest when we have 6 minutes before we need to wrap up.
Fair enough.
I would say though, it's like what Romano is pointing out in the chat is pretty interesting, which is that at the end of the day, much of everything of what we see on the screen is drawn by shaders. So a shader like the one that is applying the purling noise to simulate the water movement is also just taking in the shader that draws normally the screen. So that's like you can nest and you can nest and you can nest and you can essentially apply post effects to whatever is being drawn on screen, and that's kind of like the fancy and cool thing about shaders. But also it doesn't like shaders don't impact touch events, for example. So like the click me button wouldn't, like, it doesn't actually change shape, it just looks different, right?
Yeah.
So
yeah, if you mutate it too much, then
yeah,
then
it starts moving around. You're like, but it's always in the same spot. It's like, in a way, I don't know if you remember the first view animation framework that was only acting on the bitmaps that were drawn for the views. So before animators, where you had view animations and you could translate stuff, but it wasn't really translating, it was fake.
That's all animations, right? You just fake like the movement of it and hope it doesn't break.
Screens and mirrors. How is it? Smokes and mirrors. How is it in English?
Smoke and mirrors, yeah.
And nice. So this is very nice, and I'm very happy, Rebecca, that you could actually come and make me feel stupid once again. I really appreciate this. It's a learning experience, a growing experience.
It was not my intention.
Well,
I hope you feel like it's more achievable.
Really?
Rebecca
Come on.
can do it.
I mean-
I can do it. Come on.
no, yeah, that's not how it doesn't work like that. But yes, this was great. So Sebastian, at some point we need to add that yellow background that I think is going to be like in your standard library from today on, because I mean, can you pass on a modifier that is called yellow background? I mean, with your passion for color yellow.
Yeah, but I don't want to impose it on everyone else unless they also want it to. And Material 3 with dynamic colors kind of ruins it for me, because then it's yellow on my phone. Or maybe it makes it work for everyone. I think that's the right thing, the right approach, right? It can be yellow for me. It can be, I don't know, black for you. I don't know, whatever you like, even. Do you like colors?
Yeah, sure. I mean, yellow, right? There's a lot of yellow on myself. So I think we need to wrap up, Sebastian.
Yes,
And
I do believe so.
I can do the usual.
Let's do it. Let's do it. Let's do it.
Thank you for supporting us. We have a couple of ways for being useful to your fashion. The yellow, yes. So if you want to be fashionable like me, you can buy our t-shirt on our merch website. You can buy the battle pin. You can buy the stickers. We also have the keychain. I mean, it's getting like one of those. We have everything basically, and we also have the hoodie if it's still cold in your country. And if you have an Amazon Prime subscription, you can subscribe for free to our channel, because you can connect your Amazon account to your Twitch account, and you get one free subscription to one channel every month. And yes, thank you, Mark, for the sound. And yeah, so if you're watching this on YouTube, you can subscribe. Please subscribe. Please like. And thank you for the support. Share our videos. We also have a Telegram group where we are chatting where we are not online. I'm just gonna quickly drop the link in the chat. It's about 200 people just messing around every day and talking nerd stuff about Android and things in our world. So join us. Yeah, Rebecca, thank you again.
Cool. Thanks for having me. It was fun.
Yes. And because this time I did check in advance, well, again, next week we're not going to be streaming because I'm going to be away. I'm going to be in London. But after we're back on the 1st of March, we have Mark back with us, and we're going to be talking about, I guess, related to shaders, because we're going to be talking about game development and specifically about coding something in Unreal Engine. I have no idea what's going to happen. I have no idea how to do game development. I'm super excited about it, but also at the same time, it's C++. So there's that.
More feeling stupid. More feeling stupid. Yeah.
Exactly.
That's what we do. That's what we do. Basically, we are empowering the young developers to actually embrace the beginner mindset, right? The initial steps. The more you don't know, the better.
Yes. Exactly. So, Rebecca, thank you. It's been super cool. See you next week.
Cool. Thanks for having me.
Bye, everyone. Have a great one. Bye-bye.